Have you ever heard of or seen the Formula One World Championship? This is the most prestigious racing competition worldwide for single-seater race cars. As far back as I can remember, I grew up having a real fascination for cars, especially racing cars. I've always wondered why cars are designed like these. What influences the design of cars? Is it just the aesthetic and beauty of the exterior? Well, it's actually heavily influenced by a physics concept called drag. Drag is the force exerted by a fluid stream on any obstacle in its path or the force felt by an object moving through a fluid. In simple terms, drag is the force that opposes the forward motion of the car. It creates air resistance that pushes against a moving car. The fluid mentioned here can either be gas like the air or liquid. Drag affects the speed by which a car travels. In fact, the formula or equation for computing drag is this, where v represents velocity or the speed of the car. The drag force is directly proportional to the square of the velocity. This means that the faster the car travels, the higher the drag force increases. This explains why drag is a very important consideration for racing cars as they speed through the racetracks. Actually, the amount of drag and how this can be decreased is significant not only for the design of racing cars but also for the design of cars in general. As drag affects the speed of the car's travel, we want to ensure that the vehicles are designed to reduce drag to ensure that this does not delay our travel time. Drag also affects engine performance, as the higher the drag, the harder the car's engine works. This also has an effect on fuel efficiency since the car consumes more fuel if there is higher drag. Fuel consumption has a direct impact on our environment as it affects greenhouse gas emissions, and it will help achieve the UN's Sustainable Development Goals if we are able to design cars that effectively counteract and reduce drag. Thank you for listening.